morning, everyone. I think I can start now. First, I have to remind you, you will have to like assignment homework this week, and you also have one handling homework due next week. Handling homework 6. Okay, when you go on campus, so you will see the handling homework 6, and the deadline for this homework is the Thursday next week. Okay, Thursday next week before the incoming test. Okay. Next week we will have the test for the exams. Okay. And in this test, I will cover the chapter 7, chapter 8, and part of chapter 10. Okay. And next week we will talk more about this. Okay. And please take your handout on the table before in front of the door when you go to all. This is on the table behind you. Okay. So take your handout so you can follow the lecture easier. So we have two new handouts today. So we have the minimum sample size for estimating population mean and estimating population proportion. Okay. So that's the new things today. If you don't have the handout in the previous class that about estimating population mean, so you can get one more. Okay. So do you have any questions about the previous class? Any questions about estimating population means? Any questions? Okay, so now I will move on to the okay, it's only remaining part of the section 8.1, that is the minimum sample size. Okay, last time the purpose of this chapter is estimate two things. We will estimate the mean population, and we will estimate mean proportion. And the mean population will use for the quantitative data. Quantitative data like GPAs of students, something like that, the weight of the student, height of student, something like this. That is the quantitative data. And the mean proportion will use for the qualitative. Like the student who use Facebook, the student who use Instagram, the student who use the percentage of students use Instagram and TikTok, something like this. That's the qualitative data. Okay. And in this chapter, we will focus on how to estimate two things, like this: mean population and mean proportions. And the last time we finished how to estimate the population means, right? The population mean, that means we need to estimate mu. Okay. And to estimate mu, you know that maybe we will have the concept called the margin of error. For example, we have the point estimate here. So we have the margin of error is a distance from the point estimate to the upper estimate and lower estimate, or the maximum value or the minimum value. That is the margin of error. For example, I assume that we have mu, we need to estimate is 29, and point estimate is 28. The margin of error in this case should be 5, and I get 30, 33 and 23, right? Okay. So you see the interval from 23 to 33 is very large, right? If the margin of error is large, if the margin of error is large, So you will have the interval is large, right? And in this case, maybe we will have a lot of value. We have a lot of value from this in this interval if the margin of error is large. Okay. So now the thing here is I want to get the margin of error is small. The margin of error is small. If I get the margin of error is like 2, okay, example 2. So I only get the interval from 26 to 30. So you see that this interval will be smaller, right? So when the interval is smaller, so you can guess the mean population better than if you have the loss interval, right? Because when you have a loss interval, so you have a lot of value here. When you have a small interval, so you have fewer values, right? So the thing is, how do we get the margin of error is smaller? Okay, that is the thing. So now the thing here is we can do that if we can take a more survey. That means we will increase the sample size. We will increase the sample size. If we increase the sample size, the margin of error will be smaller. Okay, will be smaller. Okay, if you look at the formula here, if you look at the formula of the margin of error in the previous handout, I think. Okay, this is the formula of the margin of error in the previous handout. So you see that the margin of error E equal to Z alpha over 2 sigma square root of n. Okay. If the n here is large, so you see that E here is smaller. Okay. So now we will increase the sample size. This we can do, right? How to increase the sample size? For example, instead of you investigate 100 students at West State University, you can increase your sample size to 1,000, for example, like this. So you will get the margin of error will be smaller. So your estimate will be better than the estimate just few samples, few students, right? It's better if you investigate, if you survey 1,000 students, than you just survey 100 students, right? That is the thing. Okay. And today we will learn how to get the design error, design margin of error. How to get this, and we will choose. How do we choose the minimum sample size? How many sample size we need to choose to get the design maximum margin of error? For example, I want to get the margin of error is 1. So the question is, how many number of samples I need to investigate? That is the thing today. That is the purpose today. Okay, I will write down here. I want to get a desired margin of error. So the question is, what is the minimum sample size? Sample size. Okay. And so, because I want to get a design margin of error, so the question here is, what is the minimum sample size I need to do? I need to get 1,000, 10,000, or something like this. How many? Okay. So you can see on the screen, the answer is, this is the answer. The answer here. Okay. Okay, n here will be the minimum n here will be calculated by this formula. N here is equal to Z alpha over 2 times sigma square root over E squared. That is the formula to estimate the minimum n, the minimum sample size. Okay. You know how to find Z alpha if you Z alpha over 2 if you know the confidence level. Okay. And the last time you see that you can find Z alpha over 2 by using the table A.1 critical value. Okay. If you know the confidence level, so you can find the critical value for this. And standard deviation, you need the information about standard deviation. And the final one is the margin of error you want to get. For example, I want to get the margin of error is 1. So how many people I need to investigate? How many students I need to survey? Something like that, to do survey. So when E is smaller, so you will get the better estimation for the population need. Okay, basically guys, that is the purpose. Okay, so now that is the formula for this. So I will give you the example to apply this formula. And here is the example. So also on your handout, determine the minimum sample size needed if we wish to be 90% confident that the sample mean is given to units of population mean. Okay. An estimate of population standard deviation is 8.4. Okay, take your handout in front of the door. Okay. Now the question here is the population mean, right? And I want to get the distance from dump to dump is within 2 units of population mean, right? Okay, this means that 2 units, right? 2 units. That means that E should be approximately 2. Right? The distance from the point estimate to the maximum value is 2. Okay, you know that is the desired margin of error we want to get, right? And now we need to determine the minimum sample size needed. That means maybe we need to, how many people we need to do survey, how many people we need to do the investigation, something like that. And they give us the C here, the confidence level is 90%, it's 0.9, right? And they also give us the standard deviation here is 8.4, okay, 8.4. So now we have all information about this. Okay, so now we can apply the formula to get the minimum sample size. So the minimum sample size here is okay, n here is using this formula Z alpha over 2 times sigma over E squared, right? Okay, so now we need to find Z alpha over 2. We need to find, okay, sigma here. We have its sigma and we have margin of error here, E here. So the thing here, you only need to find Z alpha over 2. So to find Z alpha over 2, you will use the table A.1 in the previous handout. So could you tell me what is the Z alpha over 2 in this case? This is critical value. How do we find this? Using your table. The confidence level here is 0.9. So could you tell me what is the, okay. Madeline, please.
1.645.
Yeah, exactly, 1.645. Yeah, we have the critical value here. Okay. Okay, so now we have the information about the critical value. So we put it in the formula. Okay, 1.645 times sigma here is 8.4, and the margin of error we have here is 2. Okay, and square. Okay. And after that, you will get the result should be nearly approximately 48. So to get the margin of error is 2. So you need to investigate or you need to do survey at least 48 people. Okay. This will very important for you to make the decision. How many people you need to do survey when you want to make a good decision. Okay. Maybe if you want to smaller margin of error like 1, the margin of error is 0.5, so you need to make survey more people. Maybe not 48, you need to try 1,000 people, 2,000 people like this. Okay, clear, right? That is the purpose. Okay, that will finish section 8.1 about estimating population means. Okay, and now we will move on to the next section that we will estimating the population proportion that we will use for the qualitative data. For example, when you want to investigate or you want to know the percentage of students at one state university using Instagram or using Facebook, something like that, or other kind of social media. In this case, you should use the proportion, right? Proportion. The qualitative is different from the quantitative. Quantitative, like the GPA student, the height student, the weight student, that is different. Right? The qualitative is percentage. The percentage like this. Okay, so now we will move on to the next section. That is the estimating the population proportion. This is similar to the previous class. When you want to estimate the population proportion, sometimes it's impossible. For example, I want to investigate the percentage of students at Western University using the Instagram. So it is possible for me to do the survey for all students at Western University, right? So the thing here is I just focus on some small group. For some small sample student, maybe in my class or maybe in some other classes, I just do this. And if I do for the sample like this, so how do I get from the sample to the population? If I have the sample proportion, if I have information about the sample proportion, how do I know about the sample, the population proportion? Proportion from population, population proportion. If I know this, so how do I know about this? Okay, what the relationship between them? Okay, that is the thing we will learn today. Okay, how do we know this? Okay, so now you will look at some concepts about the population proportion and sample proportion on the screen or on your hands down. Okay. Okay. The population proportion is just the fraction of percentage of a population that display a certain characteristic. Okay. That is the definition. It's not difficult. For example, you can look at the example 1. Okay, suppose the best part would like to know if it should stock more cat products or more dog products. Okay, they randomly survey 200 adults, asking them if they own a cat or dog, and 50 people say they own a cat. Okay, own a cat. So the sample proportion here is the percentage of people who own a cat, right? So we have, okay, the sample size here is 200 people and only 50 people own a cat. So the proportion here is the 50 over 200, right? So it's approximately, it's exactly 25%. Okay. Instead of we say there are 50 people who own a cat in 200 people, we can say that the percentage of people who own a cat is 25%. Okay, is it clear, guys? That is proportion. You know how to do this? Okay. And now, if you know the sample proportion, we know P hat. How do we know about P? How do we know about P? Okay. And now we also have two methods, two kind of estimation. The first one is the point estimate. The second one is the interval estimate. As I mentioned before, as I mentioned in the previous class, sometimes the point estimate is not exact. You will not get the correct answer. Sometimes we will not use the point estimate. We will use the interval estimate. Is it better? When we get the interval estimate, so maybe P will be from this number to that number, maybe 25, B will be something like that. 25% to 35%. So we will guess that P will be 26 or 27, something like this. Or the point estimate here, we will get the P is exactly some number like this. Sometimes it will be not exact. Okay, not exact, not correctly. Okay. Okay, so then the thing, okay, that is the two kind of estimate. So what is the method? How do we estimate the population proportions? Okay, we have the method here. Okay, do you have the handout? Please get your handout in front of the table, the door. Okay, we have this condition here to apply, and what will we get? Okay, when we apply the method, you need to check the condition here. So we have three conditions. Okay, all possible samples of given size have an equal probability of being chosen. That is a simple random sample in use. For example, when you want to investigate the percentage of people who like chocolate, right? You cannot go to the chocolate shop to ask them, do you like chocolate? It's not the good sample. When you want to investigate, when you want to do survey, you cannot do this, okay? Because people when they go to the chocolate shop, maybe they like chocolate. A lot of people like chocolate, so that is not a good way to do the survey. Okay. Okay. So the condition to apply here is the first thing here is a simple random sample in use. Okay. And the second condition is the condition for a binomial distribution are met. Okay, we don't learn about this. We don't study about binomial distribution in this course. So we always assume that we have the second condition in all our exercise and homework. So you will learn this in another courses, another course. Okay. And the sample size is large. When you do that, the sample size is large enough. And it satisfies two conditions here. And sometimes in a lot of your homework, these conditions are also satisfied. Okay, if you choose the number of sample size very large, so you can get this condition easier. And that is the three conditions when we want to apply this method to estimate the population proportion. Okay, if we have three conditions like this, what will we get? We will get three things. Okay, we will get three things. The first thing, the passport estimate. The passport estimate is equal to the population proportion. Okay, that is the passport estimate. This is the first thing we get from this method. But as I mentioned you before, the best point estimate is not exact and it's not the thing we need to design. Okay, we will not use the best point estimate in the general in the general case. We don't use this. We don't use in the real life. But this will use for the interval estimate. This is the second kind of estimate. We need to find an interval estimate. Okay. And as I mentioned you, if you want to find an interval estimate, you need to find the margin of error. Okay, this is the point estimate. And you want to this distance is smaller, right? So that's either margin of error. If you know the margin of error, so you can get the interval. Okay, you can know the estimate interval. How do we know that? How do we calculate the margin of error? Okay, so you can look at your handout. You will have the formula for that. This is the formula for the margin of error. Okay, E here. The E here will be calculated by Z alpha over 2. That is critical value. So you can use the table to find that. Square root of P. Okay, this is sample proportion. It's 1 minus B over N. So you don't need to remember this formula. So you just need to know when we use this formula and when we use the formula in the previous class. Okay. If the question gives you the population proportion, so you will use this. If they give you the proportion, you will use it. If they give you the sample mean, so we use the formula in the previous handout. Okay. It depends on the question. You need to determine they give you the mean or they give you the proportion. It is similar like the chapter 7. Mean or proportion. Two things to remember. And when you have the margin of error, so you can find the confidence level. Okay, the confidence interval, or not confidence level, the confidence interval for the population proportion. Okay, so that is the point estimate plus to the margin of error and the point estimate minus the margin of error. Okay, that is the theory. And now I will give you an example to understand how do we estimate the population proportion. Okay. So now you will look at the example 2 in your handout. A survey of 345 random selected students at one university found that 301 students think that there is not enough parking on campus. The question here is find the 90% confidence interval for the proportion of all students at this university who think that there is not enough parking on campus. Okay, I will write down. So we will analyze the question. Analyzing the questions. Please get your handout. If you don't have, it's in front of the door. Okay, on the table in front of the door. Okay. So now, could you tell me what is the sample size in this case? What is the sample size in this case? Okay, Liz, please.
345.
Huh? Sorry.
345.
Yeah, exactly. And here is 345. So this is the sample size. Okay. This is the sample size. Okay, and we have C here is confidence level is 90%. It's 0.9. Okay, and that is the thing. Okay, they are nothing. Okay, just like this. And we when we have information about 300 and one student think that there is not enough parking on campus, so you can try the sample proportion. Okay? The sample proportion. The sample proportion will be equal to x over the sample size. X here is the number of the student think that there is not enough parking on campus. So could you tell me what is the sample proportion in this case? How to calculate this? Okay, look again.
Put 301 over 345, and then.
Okay. Okay, and we will get the value is 0.87, right? It's not difficult to find the sample proportion, right? Not difficult. Okay, we have all information about the proportion, information about the n. Okay, that is the first step. Step 1, you find out the sample proportion. That is step 1. We finish the step 1. We find out the sample proportion. The step 2, we find the margin of error. Okay, the margin of error will be calculated by the formula I provided here. E here is z alpha over 2 times square root of b hat 1 minus b hat over n. Okay. And now they have the confidence level. C is 0.9. Okay. So we imply that the critical value here is, you can use the table 8.1 to find the critical value. The critical value here is 1.645. That's the critical value. If you know the confidence level. And now we will relate all the things to this formula. Okay, it's 1.645 times square root of. Okay, b hat here is 0.87. Okay, it's approximately times 1 minus 0. This number over n here is 345. Okay, that is the margin of error. And using calculator, you will get the result is approximately 0.029. Okay, 3. Okay, I will round it to 2 decimal places. It's 0.03. Okay, so now we have the margin of error E. So you can find the point S, the confidence level. Step 3. The confidence level. Confidence interval. Not confidence interval. So you have the lower endpoint here is the lower endpoint. The lower endpoint is equal to the sample proportion. That is the point estimate minus to E. And the upper endpoint is equal to the point estimate plus E. Okay. So now you will get two results. You get that this is approximately 0.843 and this is approximately 0.902. And when you have this, so you can imply that the population proportion will from this number to that number, 0.843 to 0.902. So P from this value to this value, okay? That is the estimation for the population proportion. Is it clear? Any questions so far? So you do step by step. The first thing, you do the point estimate. The second one, find the margin of error. The step 3, you find the confidence level. And after that, you will get the interval for the population proportion. Okay. And after that, you will have the practice exercise here. A survey of 1,025 randomly selected students at Western University found out 820 students think that there is not enough parking on campus. Find the 90 confident level interval for the proportion of all students at this university who think that there is not enough parking on campus. So you can use the same way to find this. Okay. So that is your not your homework. This is the exercise. Exercise for you is I will give you the homework like this. This is the exercise for you to practice. Okay, try to do it. Any questions? Okay. And now we move on to the final part, the final content of this section. That is the minimum sample size for estimating the population proportion. Okay, as I mentioned you before, so if you have a point estimate here, and you have this line, this distance is the margin of error. So the thing here is I want to get the margin of error is small. If I get the margin of error is small, so you can get the fewer estimate for the population proportion. For example, the population proportion will be 75%. So if the point estimate 49, so I get the margin of error, for example, is 5, something like that. So it's very large, right? So this is 44, 50, 54, and this is 44. So you see that the value from 44 to 54 is very, very large value. So you have a lot of value here. Okay, so this is difficult for you to estimate the proportion, right? So if I have the margin of error, it just maybe 0.5, something like this. So you have the interval here is 49.5, and the interval here is 48.5, right? So the value should be from this value to this value, right? This value to this value. So you can guess the better estimate for this, right? So the thing here is we want to make the margin of error is smaller. So how do we choose? How do we choose the sample size? What is the minimum sample size we need to do? That's the question. If I want to, I write again, what I want to get a design margin of error. So the question here is, what is the minimum value of sample? How many students I need to do survey, how many people I need to do investigation, something like that. So that is the minimum value of sample size to get a desired margin of error. That is the question. Okay. So now you can answer the question by using this formula. Okay. Using this formula, the minimum sample size required for estimating a population proportion at the level of confidence with a particular margin of error will be given by this formula. I write down here. So n here is p 1 minus p. Okay, p here is we have is okay, and this is v 1 over 2 p squared. Okay, and after that we will get the desired n here. Okay, and z alpha over 2 you can find it by using the table 8.1. The critical value e here is the margin of error. We want to find this. Okay, and let's go to on let's go to the final example of today. Final example of today. We can look at the example 3. If you don't have a handout, so please get your handout in front of the door, on the table in front of the door. Okay. So now, the first thing we need to analyze the question. We need to analyzing the questions. What is the minimum sample size needed for 99% confidence interval? So now we have the confidence interval, confidence level is 0.99 because this is 99%. So that means that C here is 0.99, right? And they give you the P here or P hat here is approximately 0.54. Okay. And we design no more than 2% of margin of error. Okay, that means that E approximately 2%, right? 2%, that means is equal to 0.2 or 0.02. Okay, that is the things when we analyze it. And the thing here, we need to find minimum error. Sample size. That is the question. Okay, so now we need to write down the formula for the n here is b1 minus b square z on power 2 e squared. That is the formula for this. And now you see that P here is 0.55, 54, so you relate this. Okay, relate this. So 1 minus 0.4 times. Okay, so now they give you C here is 0.99. So could you tell me what is the critical value for this? What is critical value for this? Okay, you please. Huh? Okay. 2.6. Could you tell me again? What is the critical value here?
81% say the change to 0.01 over 2, right?
No. Not correct answer. So I ask you, if we have the level of confidence here is 0.99, so could you tell me what is the critical value Z here by using the table 8.1? 2.6. Okay, 2.6. But you okay. Please don't round it. Please don't round the critical value. So you keep it. Okay, keep it like this. Don't round it. If you round it, so you may get the answer will be not exact. Okay, so keep the value here. What's your name? Is Thomas, right? The critical value here is 2.575. So don't round it. Don't round it to 2.6. Okay. If you round it, so you will may get the result is not exact, not correct. So we put here is 2.575 over E here. The E here is 0.2 square. And after that you will get the result N here is, okay, the result N here. The result N here is approximately 4118. So that is the minimum value of N you need to do. So if you want to investigate, as you can see that the margin of error in this example is very, very small, right? So you have to make a lot of sample size. 4,118. Okay. If you want to small margin of error, so you have to pay. You have to pay that. You have to do investigation or you do survey for lots of people. Lots of people. So you get the smaller margin of error, right? That is the things. Okay. That is the minimum sample. So you can investigate 4,200 something like that. It depends on you. Okay. So but it is the minimum value you need to investigate to get the margin of error like this. Okay. That is the thing. Any questions so far? Okay, so please review your chapter A. We finished chapter A today, so please review. You have 3 handouts for the chapter A. So now I will make a handout for you. Remember, you have the handling homework 6 and due next week. Okay, on Thursday next week, and next week you will have the first test. Okay, the test. You will do at home, similar like test 1 and test 2, something like that. Now I will make the attendance. Some of you are here. Max not here. Laurel. Eileen. Bob Dean. Christopher Dollar. Shay Ely. I can see here. Robin here. Not here. Then the crossing girl. Abdul Hamid. John Beater. Kipling. Kipling here. Lead here. Chamberlain here. Ortilia. Matu here, right? Rick. You here. Tyler here. Aliyah Smith. Yossi. Sullivan. Maria here. Not here. Thomas here. Ria. Okay, thank you for your attention. Huh? Monday? On Monday? This week?
No, I didn't get to Monday of this week.
This week?
Last Monday?
Last Monday?
I didn't come.
This coming up, you didn't email to me.
Huh?
You didn't email to me, right?
Email it to you?
Yeah, when you want to be absent in class, so you need to email me before the class starts.
Okay.
Next time you can email me. I cannot go to the class on that day because of some reason.
No, I was just saying it for the point.
Huh?
I was saying it for the point, right?
The attendance? Okay, so this is okay. I can give you the appointment, the for attendance for this, but the next time I cannot accept it like this.
Okay.
You need to email me before. Okay.
Okay.
Let me write down. Okay, I wrote down. Thomas, right? Monday. But let me know before the class starts.
Okay. Thank you.
What happened?
Professor, I emailed you, but you're not responding.
No. The last time you emailed me, not the class to start, right? You emailed me at 11, right? Okay, but I can give you the point for this. But not the next time you'll be. Please let me know before the class starts, right?
Okay. No, I didn't know we have class.
Yeah, Monday we have class.
No, I thought we were still on spring break.
Yes, spring break we have no class on spring
Okay.
break. Of course, we will not have class on spring break.
Okay.
Okay, thank you.
What is our next exam?
Exam 3. Exam 3 on next week on Friday.
Oh, okay, upcoming.
Yeah, it's coming.
Okay.
It's chapter 7, chapter 8, and a part of chapter 10.
Okay.
Okay, spend time to review all the
Yeah.
materials. Okay. I know you get a high score in my class, but try to go to class. Okay.
Okay. I got you. Now these is it the PowerPoints?
Huh?
Are these the?
Yeah. No PowerPoint. This in this chapter. I
Oh.
only give you the handout for this.
Because I like the PowerPoints because I use my iPad.
Yeah.
You know what I mean?
What is it?
for the PowerPoints, I use my iPad,
Yeah,
my iPad device
device.
to write on.
Yeah, it's on the canvas. I put everything on canvas so you can see here. So this is on here. It's not PowerPoint, but it's the PDF file, and you can see here. So it's the handout that just put on this, then you can see the PDF file. Okay, you can use on iPad. Okay, you can take note of this. No problem.
Okay.
It's similar like
Because
the
I use it
PowerPoint.
because I use it on my iPad.
Yeah,
Okay.
you can do this. No
Thank you.
problem for this.
Have a good day.
Yeah, you too. Thank you.